Hi, everybody. I'm Alan Rubin at UCLA. Today I'll be talking about meteorites, the road to recognition, how scientists, geologists, and naturalists in the 17th and 18th centuries recognized the phenomenon of rocks falling to Earth from the space. For thousands of years, there have been reports of rocks falling from the sky. Here, for example, is a painting by Rene Magritte from 1958 called Clear Ideas. That rock perhaps is falling and perhaps is just hovering above the water. In the 6th or 7th century, before the Common Era, the book of Joshua in the Bible states that as the Amorites fled before Israel, while they were going down the slope of Beth Horon, the Lord threw down huge stones from heaven on them as far as Azekah, and they died. The passage conflates these huge stones with hailstones. There were more who died because of the hailstones than the Israelites killed with the sword. Here's a large hailstone about 6 centimeters in diameter that's been preserved. This scenario seemed credible to geologists in the 18th and 19th centuries because people were known to have been killed by hailstones, including English soldiers in Chartres, France, in 1360 during the 100 Years' War. Psalm 18:13 seems to distinguish hailstones from a hotter rock. It states, "The Lord also thundered in the heavens, and the highest gave his voice, hailstones and coals of fire," saying there's two different kinds of rocks apparently falling from the sky. Many contemporary naturalists at the time agreed with Edward King in 1796. He was an English barrister and antiquarian who stated that we should also be led to perceive that the objections to Holy Writ, founded on a supposed impossibility of the truth of what is written in the book of Joshua concerning the stones that fell from heaven on the army of the Canaanites, are only found in ignorance and error. He embraced the idea that rocks fell from heaven. If we look at the book of Revelations, which was written in the 1st century of the Common Era, it states in Revelation 16:21, "And there fell on men a great hail out of heaven, every stone about the weight of a talent." Now, a talent is in the range of 33 to 50 kilograms, far larger than any known hailstone. The largest authenticated hailstones in modern times are only about 1 kilogram, so stones much more massive than this could not be hail. The reason I'm concentrating the Bible so much is because it played a very big part in the thinking of naturalists at the time. But the Bible seemed to indicate that very large rocks, much bigger than any known hailstone, fell from the sky. European geologists were well acquainted with volcanic bombs falling to the ground. Here's one from the Kilauea volcano in 1983. Pliny the Elder was in charge of the Roman Navy, and he sent ships to rescue people from the eruption of Mount Vesuvius on August 24th in 79 CE. His nephew, Pliny the Younger, wrote, "The ash became hotter and thicker as the ships approached the coast, and it was soon superseded by pumice and blackened burnt stones shattered by the fire. Suddenly the sea shallowed where the shore was obstructed and choked by debris from the mountain." So this is the eruption of Mount Vesuvius. And again, they were well acquainted with rocks falling from the sky that had been blasted into the atmosphere by a erupting volcano. Here's a painting of this event. '18th and 19th century naturalists are also aware of fabulous reports, i.e. fables, of peculiar substances falling from the sky. There were reports of flesh and milk and blood and wool, baked tiles, paper, and even gelatin coming from the sky. Some of these reports were from Pliny the Elder's book, Natural History. So it was a difficult problem to sort out what might be real phenomena from phenomena that were obviously fictitious. This book, Pliny the Elder's Natural History, also contained a credible report of what might be a shower of pallasites. Pliny wrote, "It also rained iron among the Lucanians the year before Crassus was slain by the Parthians, as well as all the Lucanian soldiers, of whom there was a great number in this army. The substance which fell had very much the appearance of sponge, Now look at the two words here. It also rained iron with the appearance of sponge over here. Now, here's a palisite and there's a sponge. From a distance, you can see that there's a matrix here with lighter material in it, which could be somewhat akin to sponge. But palisites have long been described as sponge-like. Parch in 1834 said the Imelec palisite had a knotty or sponge-like appearance. Farrington in 1915 wrote that palisites consist of a sponge-like mass of nickel iron, the pores of which are filled with chrysolite, which is magnesium olivine. And George Merrill in 1934 wrote palisites contain olivine in a continuous network or sponge of metal. So this report may well have been that of a palisite. Pliny the Elder also said, I myself saw a stone that had just fallen in the territory of the Vocantians on the western foothills of the Alps in Gaul. So there are also several stories of meteoritic stones that were enshrined in ancient temples. Pausanias reported that the sacred stone in Delphi was the very one that was given to the Titan Kronos, which is the same as Saturn, by Rhea in place of the infant Zeus, and was hurled to earth after Zeus later dethroned Kronos. So here's the story. Kronos was afraid that his kids would usurp him, and so every time Rhea gave birth, he would swallow the baby whole, and in this case, she gave him a fake Zeus. And instead of giving the baby Zeus, she wrapped up a stone in swaddling cloths and he just swallowed it whole. And then the report is that this later fell to earth after it was disgorged from Kronos. And at the museum in Delphi, there is this, at least a copy of the sacred stone that must have fallen to earth. Another one of these stones that were enshrined in ancient temples, Tacitus described a conical stone that was stored in the temple of Aphrodite. Herodian reported that a large stone was venerated in Emesa, Syria, and brought to Rome by Elagabalus, who demanded its public worship. And Pliny the Elder reported that two stones were venerated, one in Egypt and one in northern Greece. An individual sacred stone was known as a Bethel, which is Semitic for house of God, or Beth El, or an omphalos, which is Greek for navel or loosely center, as in the belief that Delphi was the omphalos or the center of the world. The depictions, let's just go back here. Look at these stones here. They are in the temple. You can see that they're conical. They look very much like the one at Delphi. And the depictions of these sacred stones show them having these conical shapes, just like oriented meteorites. Many people believe that these coins depict real meteorites. Now, fireballs are a separate phenomenon. They were seen typically by thousands of people, but meteorite falls are a much rarer phenomenon, and they're generally witnessed by very few people and generally by no professional naturalists. Most late 18th and early 19th century naturalists did not recognize any relationship at all between fireballs and reports of falling rocks. They relied on Aristotle, who wrote in Meteorologica in about 360 BCE, where he stated that fireballs arose from dry exhalations from the earth, such as steam and smoke from volcanoes. Isaac Newton asserted in Optics in 1704 that sulfurous steams at all times when the earth is dry, ascending into the air, ferment there with nitrous acids, and sometimes taking fire cause lightning and thunder and fiery meteors. Ben Franklin, the American polymath, showed in 1752 that lightning was an electrical phenomenon. 1 year later, in 1753, John Canton suggested that aurorae were caused by the movement of electrical fire from positive and negative clouds at a great distance through the upper parts of the atmosphere. Shortly after 1000 CE, the Islamic philosopher Avicenna suggested that both stony and iron objects could fall from the sky. They formed there due to the accidental qualities of coldness and dryness, which fieriness acquires when it is extinguished. He was presumably taking a lot of these ideas from Aristotle. In 1544, the German mineralogist Georgius Agricola insisted that rocks could not be formed in the air from dry exhalations. If rocks indeed fell from the sky, they must have first have been uplifted to the sky by fierce winds and whirlwinds. In the mid-17th century, René Descartes proposed that stones could form in the clouds from small particles fused by heat associated with lightning. Such rocks are sometimes called thunderstones or lightning stones. The French scholar Nicolas Ferret said if stones indeed fell from the sky, they must have been ejected by distant volcanoes and blasted along trajectories. They carried them hundreds of kilometers from their source. Coincidentally, the Siena L5 chondrite fall, which is on June 16, 1794 in Italy, occurred just 18 hours after the eruption of Mount Vesuvius, which is about 400 kilometers away. So some people connected the two phenomena. Diderot's encyclopedia from 1757, that edition, described thunderstones as mineral matter fused by lightning. A decade later, some mineralogists asserted that thunderstones did not fall from the sky, but were instead produced on Earth by lightning, making them something like fulgurites, such as this object over here on the bottom. These indeed form on the ground from lightning strikes, but they were not recognized as such until the beginning of the 19th century. A number of different kinds of thunderstones were around in the late 18th century. They included stony and iron meteorites and fossils of squids and sea urchins and shark teeth and sulfide concretions and even Stone Age hammers, spearheads, and axe heads. So there was a peculiar and eclectic assortment of objects, making things much more confusing. A major impediment for accepting the idea that stones indeed fell from the sky was that there were very few bodies from which these rocks could be derived. In 1704, Newton wrote in Optics that to make way for the regular and lasting motions of the planets and comets, it's necessary to empty the heavens of all matter, except perhaps some very thin vapors, steams, or effluvia arising from the atmospheres of the Earth, planets, and comets. He was following Aristotle and suggesting that space was empty. Another difficulty that 17th, 18th century scientists had was that the phenomenon of rocks falling from the sky could neither be predicted nor verified by experiment, making it a hard to test phenomenon. In 1665, in Micrographia, the English polymath Robert Hooke made a clay water slurry and dropped musket balls into it. He noted that the resulting pits resembled lunar craters. Galileo had started observing the moon more than 50 years earlier with the telescope. However, Hooke rejected the idea that the craters were formed by impacting projectiles because it would be difficult to imagine whence these bodies should come. He concluded that the craters were volcanic because he knew about volcanic craters, but they were far larger than any known volcanic crater on Earth. The only two permanent celestial bodies in the sky with a substantial angular diameter are the sun and the moon. Both were cited as possible sources of meteorites. Pliny the Elder related a story about the Greek philosopher Anaxagoras, who had amassed so much astronomical knowledge that he predicted that on a particular day a stone would fall from the sun. Pliny was skeptical. Our knowledge of the nature of things, and indeed everything else, would be thrown into confusion were we to suppose either that the sun is itself composed of stone or that there was even a stone in it. Yet there can be no doubt that the stones have frequently fallen from the atmosphere. So Pliny accepted the idea that stones fell from the sky and iron fell from the sky, as we saw earlier. But again, he was aware that Anaxagoras had suggested that a stone had fallen from the sun. There are also transient lunar phenomena. These are short-lived flashes of light. They were reported on the moon by numerous telescopic observers in the 18th and 19th centuries. These phenomena were widely attributed to be volcanic eruptions. Many great observers, like William Herschel, reported such phenomena. Modern explanations, however, include the real impacts of meteorites and comets, also outgassing through fractures in the lunar crust, electrostatic forces, thermoluminescence, terrestrial atmospheric turbulence, producing fictitious lunar transient phenomena, poor telescopic optics, and of course, overactive imaginations. The Bremen physician and astronomer Heinrich Wilhelm Olbers was the first to propose in 1795 that meteorites might come from lunar volcanoes. Pierre Simon Laplace, the French polymath, independently suggested in 1802 that meteorites could be lunar volcanic ejecta, and this was quickly endorsed by the French physicist and mathematician Jean-Baptiste Biot. There were 5 developments in the late 18th and early 19th centuries that firmly established the fact that rocks fall to Earth from space. First, Ernst Chladni wrote a 63-page treatise proposing that material from interplanetary space entered the Earth's atmosphere, producing fireballs and dropping meteorites. He argued against the notion that interplanetary space was necessarily empty. He explicitly stated that fireballs are the luminous manifestations of rocks from interplanetary space traversing the atmosphere, undergoing intense frictional heating and falling to Earth. So he linked fireballs and falling rocks. Chladni listed 18 observed falls from ancient times to recent times. He also said that large masses of iron that had not been observed to fall, such as Campo del Cielo, were also meteorites that had fallen to Earth from the sky. The second link was that 2 German physicists simultaneously observed meteors in the night sky in September and October of 1798 from sites 15.6 kilometers apart. Their measurements indicated that meteors are visible at altitudes ranging from 170 kilometers to 26 kilometers. They're traveling at very high velocities, 29 to 44 kilometers per second. It seemed impossible for rocks to be lifted off the Earth by whirlwinds or exhalations to such heights or reach such high velocities. The objects producing the meteors must have originated in space. Third, there was an appreciable number of meteorite falls after Chladni's book was published. Siena in Italy, an LL5 chondrite, fell in 1794. Wold Cottage in England, an L6, fell in 1795. Portugal, an unclassified stone that was lost, fell in 1796. Celis, France, an L5 chondrite, fell in 1798, as did Benares in India, an LL4 chondrite. L'Aigle in France, an L6, fell in 1803. And Weston, Connecticut, fell in the United States in 1807. That's an H chondrite regolith breccia. Also, reports of the Barberton, France fall from 1790 was called to the attention of scientists after Chladni's books was published because the fall had not received much attention before that time. Siena was a modern city with 30,000 residents. Many people witnessed the fall, and the rocks were studied by scientists throughout Italy. Wold Cottage was observed to fall by several witnesses. The landowner, Major Edward Topham, exhibited the stone and erected a brick monument where it fell. Topham was a well-known soldier, newspaper publisher, dog breeder, and fashion icon. His sterling reputation and his great notoriety led many to accept the eyewitness reports of his workmen as honest accounts because he was so credible. Here's a picture of Edward Topham in his typical finery. About 3,000 stones fell in L'Aigle, France in 1803, an event witnessed by dozens of people from all walks of life. Biot, who was professor of mathematics at the Collège de France, interviewed numerous witnesses and drafted a sensational report. Large portions of this report were published in scientific journals as well as in daily newspapers and monthly newspapers. Biot wrote, "All persons so diverse in professions, customs, and opinions having little or no relations with one another agree all of a sudden to testify a same fact that they have no interest to suppose." He noted the physical effects of the fall, broken tree branches and holes punched into the soil by small stones. He compared numerous specimens and found them all alike, all similar to each other, yet different from rocks in the surrounding countryside or to products of local foundries or slag from nearby mines. Fourth, there was Howard's report from 1802, which contained analyses of many meteorites showing that they all contain nickel. This indicated a common origin. Nickel is so rare in the Earth's crust that it had only been discovered a half a century earlier in 1751 in the mineral nickelite, nickel arsenide, by the Swedish chemist Baron Axel Kronstedt. Here's a copy of Howard's 1802 report. Howard began this paper with a clear declaration. The concordance of a variety of facts seems to render it most indisputable that certain stony and metalline substances have, at different periods, fallen on the earth. Whence their origin or whence they came is yet, in my judgment, involved in complete obscurity. Associated with Howard's paper, it was one by the French mineralogist Jacques-Louis Comte de Bornon, who had fled to England to avoid the Reign of Terror. Bernal was the first to describe chondrules as small bodies, some of which are perfectly globular, others rather elongated or elliptical. Fifth was the discovery of asteroids. Here's Ceres, the largest asteroid. This is also an interesting story here. So Bode's law is a mathematical gimmick discovered in the 18th century by a German astronomer, Johann Titius, that provides a quick and dirty way of estimating a planet's mean distance from the sun. It doesn't describe where the planets formed. It only shows the closest spacing of planets that's dynamically stable over billions of years. Here's a simple formulation of it. Start with the numbers 0, 3, 6, 12, doubling every number after number 3. Add 4 to each number and then divide by 10. The asteroids are treated as a single planet. This yields the approximate distance from the sun in astronomical units for each planet from Mercury to Uranus. William Herschel had discovered Uranus in March 1781. So here's the distances derived by Bode's law on the left and the actual mean distance on the right. We can see the tremendously good correspondence. Mercury is at 0.39 AU, Bode's law says 0.4. Venus is at 0.72 AU, Bode's law says 0.7. Earth is 1 by definition. Mars is at 1.52, Bode's law says 1.6. Nothing was at 2.8. Jupiter, by both Bode's law and the actual distances, are at 5.2. Saturn is at 9.54, Bode's law says 10. When Uranus was discovered at 19.2 astronomical units, and Bode's law said 19.6, they realized that there's probably something to this law. So after Herschel discovered Uranus, and that planet's orbit had been well determined, Johann Bode, director of the Berlin Observatory, pointed out that Uranus's distance from the sun matched the law. So he began organizing a group of astronomers, which he called the Celestial Police, to find the missing planet at 2.8 astronomical units. From that point on, this relationship is commonly known as Bode's law. On the first night of the 19th century, January 1st, 1801, Father Giuseppe Piazzi was recording positions of stars in Taurus while correcting a star catalog. On the following night, January 2nd, he noticed that one of the stars he had recorded had moved 4 arc minutes retrograde. By January 12th, it had changed its direction, began moving prograde. It looked just like the movement of a superior planet in opposition. When Piazzi later received the invitation to join the Celestial Police, he realized that he had already found the missing planet, and this was eventually called Ceres. It's located at 2.77 astronomical units. The next year, on 28th of March, 1802, Olbers discovered Pallas, located about the same distance from the sun as Ceres. Carl Harding found Juno in 1804, and Olbers found Vesta, the second largest asteroid, in 1807. All 4 of these bodies appeared as pinpoints of light in telescopes. They look different from the extended disks of planets in telescopes. These objects were therefore called asteroids, star-like. More asteroids were later discovered. There are now more than 1.1 million that have been cataloged. The English geologist Reverend William Buckland wrote in an 1820 paper, The Connection of Geology and Religion Explained, that, and by its connection with such objects as the origin of aerolites, which are stony meteorites, calculations on the depth of the sea and mean density of the earth, and the investigation of the second causes that were employed by the gradual arrangement of the matter of which our planet is composed, and in producing the overwhelming conclusions that appear at distance intervals to have affected it, geology becomes associated with astronomical speculations. By 1820, it was clear that meteorites were widely recognized in the scientific community as rocks that really do fall to Earth from space. What are the potential sources of meteorites? One is interstellar space. Chladni himself proposed that meteorites might be interstellar objects because observations of many meteors and fireballs seem to indicate that they were following hyperbolic orbits and hence were not gravitationally bound to the solar system. If an object was in the solar system, it had to be on a circular or elliptical orbit, not a parabolic or hyperbolic orbit. Many subsequent observations appear to confirm this conclusion that they were on hyperbolic orbits, but it wasn't until 1959 that all observational astronomers agreed that meteoroids entering our atmosphere were on elliptical orbits and hence were bound to the solar system and part of the solar system itself and were not from interstellar space. The second possible source of meteorites were asteroids. The inference that more than 99% of meteorites are derived from asteroids is based on many links between meteorites and asteroids. This is going to modern times now. The first of these links is that many meteorites are made up of broken fragments consistent with the cratering record of asteroids. We see a cratered asteroid here, Gaspra, and a brecciated meteorite here, the AB enstatite chondrite. Second link between meteorites and asteroids is that Jupiter flings asteroids into Earth-crossing orbits. There are presently more than 25,000 near-Earth asteroids. The largest one, Sisyphus, is 8.5 kilometers in diameter. About 7% of these asteroids will eventually strike Earth. Third link between meteorites and asteroids is the cosmic ray exposure ages of meteorites that indicate that their immediate parent bodies were meteor-sized objects traveling through interplanetary space. The age of stony meteorites range from about 30,000 years to 70 million years. This interval matches calculations for objects reaching Earth from the asteroid belt. Fourth, bodies near the sun are blasted with high concentrations of solar wind gases such as hydrogen, helium, neon. More distant bodies acquire lower concentrations of these noble gases. The abundance of solar wind implanted noble gases in some meteorites and the regolith breccias is consistent with their acquisition at about 3 astronomical units, at about the distance of the center of the asteroid belt, more or less where Ceres and Pallas are located. Here's the sun sending out a solar wind. The fifth link between meteorites and asteroids is the fact that some meteorites contain solar wind gases, indicating that their parent bodies didn't have atmospheres. This is consistent with these bodies being asteroids which are too small to have retained atmospheres. Sixth, the old formation of meteorites, they're 4.56 billion years old. This indicates they came from small bodies that could not retain heat for long periods. A warm body radiates heat into space, as we see in the picture here. Small bodies, like asteroids, have high surface to volume ratios and lose their heat quickly. The seventh link is that different minerals, it's from spectral reflectivity. Different minerals absorb and reflect light at different wavelengths. Laboratory studies of the spectral reflectivities of certain meteorites closely match those of certain asteroids observed telescopically. We can see here that Vesta reflectivity curve looks like that of ensatite and plagioclase, the two main minerals in basalt. C-type asteroids look like looks like the spectral reflectivity of carbonaceous chondrites. The eighth link between meteorites and asteroids is the orbits of dozens of photographed meteorites and fireballs are similar to those of Earth-crossing asteroids with aphelia in the asteroid belt. Here's a diagram indicating the orbit of Jupiter and the orbits of various Apollo asteroids. The orbits of these meteorites, the inferred orbits of these meteorites which fell on Earth, which are very similar to that of Apollo asteroids. The ninth link is that the slow cooling rates of meteorites indicate derivation from parent bodies only a few hundred kilometers in diameter. This is the size of many of the large asteroids. The 10th link is that meteorite fragments were recovered from a specific asteroid. Asteroid 2008 TC3, which is only 4 meters across, was discovered telescopically in October 2008, only 20 hours before it fell into the Sudan. Numerous meteorite fragments, like from the Almahata Sitta Uralite, were recovered in the desert 2 months later. Asteroid 2018 LA, which was only 2 meters across, was discovered telescopically in June 2018, only 8 hours before it fell in Botswana. Meteorite fragments, which is the Motapi Pan Howardite, were recovered 5 days later. Here's Itokawa. Samples were retrieved from Itokawa, and here are some of the samples from that. Here's the dust trail after the entry of asteroid 2008 TC3, and there's the Almahata Sitta, well, one fragment of the Almahata Sitta Uralite. Here's asteroid 2018 LA, seen here, and here's the associated meteorite, the Howardite Motapi Pan. And chondritic material was returned from 2 asteroids. I showed you a picture of Itokawa before. Here's an LL ordinary chondrite samples were retrieved from Itokawa by the Hayabusa spacecraft, and CI carbonaceous-like samples were retrieved from the asteroid Ryugu by the Hayabusa 2 spacecraft. Material was rejected was ejected from the asteroids by energetic collisions. That's how they got dislodged from the asteroids and eventually found their way to Earth. Okay, so possible sources of meteorites included interstellar space, which we could discount, asteroids, which of course is the main source of meteorites, and another source was the moon. A lunar volcanic origin for meteorites had been proposed by Olbers, Laplace, Biot, and others. However, there were three problems with the suggestion that meteorites originated from lunar volcanoes. The velocities of meteoroids are tens of kilometers per second, which seems too high to have been disgorged from lunar volcanoes. The American astronomer Benjamin Gould calculated in 1859 that only 0.00006% of rock fragments from lunar volcanoes would likely reach the Earth. 2/3 of these, of course, would fall in the ocean. This paltry number seemed grossly inconsistent with the about 160 meteorites that were known at the time. Finally, Grove Carl Gilbert, who was the senior geologist at U.S. Geological Survey and one of the leading geologists in the United States, wrote in 1893 that lunar craters were likely formed by collisions, and they were not volcanic. Well, we do have some lunar meteorites. Here's the lunar meteorite Allen Hills 81005 that was picked up on the Antarctic ice in January 1982. A thin section was examined by Brian Mason at the Smithsonian in Washington. It showed the rock to have many of the characteristics of the Apollo samples returned from the moon in 1969 to 1972. I was a postdoc at the Smithsonian at the time, and Brian showed the section to me. This demonstrates that the moon was indeed a source of meteorites. There are now about 550 known lunar meteorites. They were not disgorged from volcanoes, but were instead launched from the near surface by meteoroid collisions. The fourth potential source of meteorites is Mars. The recognition of the first lunar meteorite in 1982 rendered it plausible that some meteorites might come from Mars. There were 6 suspects. Chassigny, which is a dunite, a rock made of olivine. It fell in France in 1815. Shergatti is a basalt, which fell in India in 1865. Nakhla was a clinopyroxenite. It fell in Egypt in 1911. Lafayette, also a clinopyroxenite. That was a find that was found in Indiana in a drawer at Purdue University in 1931. Governador Valadares was a clinopyroxenite find also that was found in Brazil in 1958. And finally, Zagami fell in Nigeria in 1962. Here are three of the suspected Martian meteorites: Shergatti, Nakhla, and Lafayette. Watson and Wetherill suggested in 1979 that a Martian origin was plausible for these rocks because ejecta from Mars was expected to be differentiated, appreciably shocked, and have relatively young crystallization ages. These 6 samples are all differentiated. The basalts are all significantly shocked, and Shergatti was found to have a crystallization age of 1.3 billion years, which is young compared to the age of the solar system of 4.56 or so. The case for the Martian origin of these meteors was settled after it was shown that first, the Martian atmosphere is a unique volatile signature among solar system bodies, and second, that the abundances of noble gases within a melt pocket in one of these purported Martian meteorites, elephant moraine 79001, closely resembled that of the Martian atmosphere measured in situ on the surface of Mars by the Viking spacecraft in 1976. Here's a diagram showing this thing. Here is the Martian atmosphere as the y-axis. The x-axis is the gas from a melt inclusion in the elephant moraine 79001 glass. We can see that the different isotopes of xenon, krypton, neon, argon, 2 isotopes of argon, the abundance of N2 and CO2 all form on a line showing the one-to-one correspondence between the Martian atmosphere measured in situ on Mars and the gas trapped in this melt pocket, which was trapped there during melting as the rock was, during minor melting, as the rock was launched from the surface of Mars. An additional signature of Martian origin is the similarity in the deuterium to hydrogen ratio of the Martian atmosphere and the few hydrous phases in some of these presumed Martian samples. The ratio on Mars in these Martian meteorites is about 5 times higher than the terrestrial value, as we can see over here. Today, there are presently close to about 340 known Martian meteorites. Martian meteorites were launched by high energy collisions. Nearly all Martian meteorites have been strongly shocked. This is a result of the great amount of energy. Well, Martian basalts have been strongly shocked. This is a result of the great amount of energy required for the ejecta to reach escape velocity. If we map the percentage of masculine light-rich basaltic samples against the parent body escape velocity, assuming that the eucrites are from Vesta, lunar meteors are from the moon, and the shergottites are from Mars, we can see a good correlation here, showing that you need to pour in more energy to create masculinite. For bodies that have that are more massive, their escape velocities are higher, and so more energy is required to lift them off the surface. No meteorites are presently known to have been derived from any sources other than asteroids, the moon, and Mars. Which brings us to the question, so if meteorites are real, what's next?